Hey, welcome to this first video in a series where we're going to deep dive into WebAssembly. Now, of course, in this first video, we're going to understand what WebAssembly is and why it's important. And then we will actually be hand coding our first WebAssembly module. Now, in reality, you're probably never going to hand code WebAssembly for real world projects. You will always use a high level language such as C or C++ or Rust or assembly script to create that WebAssembly for you. But if you don't understand what WebAssembly is and you don't understand the instructions and the code that underpins WebAssembly, then you're not going to know what the compilers are doing to translate that high-level source code into WebAssembly. So really by gaining that in-depth understanding of WebAssembly under the hood and be able to hand code it yourself, then you're going to have a deeper understanding of what's going on in the browser or in the back end, and therefore you're going to be able to write your higher level language source code much better. And then that's what we're going to focus in on this video series. So the first question you're probably asking is, what is WebAssembly? Now, if we think about the world that we've been living in for the last 25 years or so, there's really only been one programming language that the web and the web browsers support, and that is JavaScript. So if I want to write a piece of code and I want that to run in the browser, I have to write it in JavaScript. Now, there are other languages that, of course, that you can create to target browsers, but at the end of the day, they are going to be transpiling the code back down into JavaScript. So TypeScript is a perfect example of that, where a lot of people are writing TypeScript today, but underneath the hood, when you want that to run in a browser, it needs to get transpiled back down into JavaScript to be able to run. WebAssembly changes the game because now JavaScript isn't the only language that can be run in a browser. There is a second language, and that language is WebAssembly. So what does that mean for the web and the average web developer? Well, the first thing to think about is WebAssembly is fast. Because it's a bytecode, because it's not dynamically compiled and it's a statically compiled code base, and because it's a bytecode language which is very close to what the machine will be executing, then therefore it's going to run fast. Think of it as near native performance. And also you have a much smaller compilation steps, which I'll go through in a second. The second thing is it's very efficient. It creates very small code bases, so it's really transportable. And then the third thing that's really important there is it's actually really interoperable with JavaScript. So it's not a situation where you can say, I'm going to choose JavaScript or I'll choose WebAssembly. They're really easy to interop between each other, because you can think of WebAssembly modules as being equivalent to ES6 modules. So therefore you can sort of call functions from WebAssembly, or WebAssembly functions can call functions in JavaScript. So we've got great interoperability between the two languages and ecosystems. The next thing that is really important is because WebAssembly is so low level, it actually enables other languages to utilize and target it. So for example, as I said, there are compilers to WebAssembly from Rust, from C++ and C, and obviously there is one called Assembly Script, which is like TypeScript but compiles down into WebAssembly. So that opens up lots and lots of other ecosystems and languages to be able to utilize the web. Now that's important because there's lots of companies who've got old code bases, maybe 25 years, 30 years plus, which are built in a different language, and therefore they can reuse and liberate that source code to create really fast, efficient code that can be running in a browser. And that's super cool. And there's lots of examples and demos of that today. And then probably the last thing that I think is super important is that it's secure. It runs in a sandbox environment, and therefore it doesn't have access to things like your file system or anything else on your machine that you wouldn't want WebAssembly code to be able to access. Now, you can give permission to access these things, right? And there's lots of very cool stuff in progress just now, but by default, it doesn't have it. It's a sandboxed environment. Now, as exciting as WebAssembly is for the browser, it's actually super exciting for the backend as well. Because it's sandbox and secure and efficient, and it's essentially a portable bytecode, then actually a lot of people are thinking about this as a replacement for containers in the future. If I want to run executable code on my backend solutions that are really secure and tiny, then guess what? WebAssembly is going to provide that capability as well. So that's really, really exciting stuff. And then we'll talk about how that could work in the backend systems. And a lot of companies are doing that just now as well. So if you look at things like blockchain, for example, things that are powering smart contracts is essentially WebAssembly code. And that's not the only example of that. I've seen companies like Shopify, for example, allow you to give custom WebAssembly code that you can run in the backend to execute your operation. So WebAssembly is going to be huge. And again, it's probably going to challenge things like containers, Docker containers in the future. So to give that even smaller sandbox environments for you to run your code. So what we're going to do now is just before we start coding our own WebAssembly modules and deep diving into that, I thought it might be fun just to show a WebAssembly application that someone else has written. I think it's really cool. It's an old ZX Spectrum, which somebody has converted into running in WebAssembly. So essentially you have a ZX Spectrum running in a browser. Actually, let me just bring that up on my machine. So if we just run that, I'm going to hit the reset button here so you can kind of see the cool startup sequence. So we'll just hit soft reset and cool, right? And then it's got a kind of this 1982 Sinclair research, so really retro, etc. And actually, you can even code against this. So we could do a hello world, but within WebAssembly in a basic programming language. And right, let's show you what I mean. So if I just type in 10, print, and then we'll just do hello world, and then we'll do the classic Spectrum thing, which is 20 go to 10, and then we'll just hit run, and then you can see hello world all the way down, and then you can just keep scrolling and scrolling and scrolling. So that's a little bit of a different hello world. What we've done in this case is within a browser, we are running a ZX Spectrum machine with the power of WebAssembly. And then we've written hello world in basic language and ran that within the Spectrum running within the browser. Really cool. But loads of other people have been doing amazing stuff as well with that. They've been running things like Game Boys or taking DOS or Windows, running all versions of Windows in browsers, which is kind of cool. So if you want to prove backwards compatibility of old machines, you can start to translate that old code and then run it in your web browser. And you can imagine where that's going as well, right? You can then start to run Docker containers or Linux containers within your browser as well. So I think the possibilities are endless in this case. So now that we know what WebAssembly is and why it's important, why don't we just go ahead and start hand coding our very first WebAssembly file. So in order to do that, the first thing we're going to do is bring up VS Code. So if we just go into my machine for a second, and we will just open up VS Code. In order for us to hand code WebAssembly, it makes sense for us to use one of the Visual Code extensions. So if we go into our extensions palette for a second, VS Code, and we just type in WebAssembly, and you're going to see this WebAssembly Toolkit for VS Code, and it's published by the WebAssembly Foundation. So if you just click install for that, that will download and install that, and that's all you need to be able to get things like syntax highlighting as you start creating your WebAssembly modules. So now that we have the VS Code WebAssembly extension installed, let's create our first module. So I'm going to open up Terminal for a second. I want to just create a working area for us to create our code in. So we'll just do a make dir, we'll call it Wasm play 2 in my case, and we'll just cd into that. And what we're going to do is create a new file, and we'll call it empty module. So this is going to be the most boring file you can imagine, right? It's just going to be an empty module. So we'll just call that empty-module. Now, when you're hand coding WebAssembly files, the file extension you should use is WAT, W-A-T, and that stands for WebAssembly Text Format. And that's a textual representation of a WebAssembly binary, which we'll produce a little bit later on. So we'll call this empty module.wat, which is a great name. So we'll touch that. And then now that I've created my empty file, I'm just going to open this up in VS Code. So I'll just type in code space dot, and that will launch VS Code into the directory that we have specified. So let's just make this a little bit bigger. We'll clear that. And to create our very first module in WebAssembly text format, we are going to type open parenthesis module. And that's it. That is the most basic module you can create in WebAssembly format. So it literally is a empty module, and that is in WebAssembly text format. So what we'll do now is compile that module, see what the bytecode looks like, and then we will make it a little bit more interesting, maybe add some numbers, etc. to that. So unfortunately, I can't take that WebAssembly text format file that I just created. I can't take that and just plonk it in the browser and run it, because the browsers only understand the binary format, the .wasm format or WebAssembly module format. So what I'm going to have to do is run it through some sort of compiler, which will take that WebAssembly text format and convert it into bytecode, into the WebAssembly module bytecode. And there is actually a tool that does that. It's part of the WebAssembly binary toolkit, or as it's otherwise known as is WABT. So a little bit more fuddy there, WABT, WABT. And there is a tool within that toolkit, which is called WAT to Wasm. And you can kind of guess what that does, right? WAT, as in WebAssembly text format, to Wasm, WebAssembly module. And all you would do is pass in the name of the WAT file and then output the name of the Wasm file that you would want, and then it would create it. So we can actually just draw that up on the iPad for a second. So if I have a first box here, and we'll call that empty module .wat, and then I'm going to pass that into WAT to Wasm, and it's going to output my empty module .wasm. So now we understand how that works, what we're going to do is download the toolkit and then compile it. So to install the WABT toolkit, the first thing you need to do is just understand where it lives. So if we go on to github.com, you will see under the WebAssembly organization, there is a WABT repository. And that's really what we are going to download and install. And if you've got time, you feel free to have a look at it. There's lots of interesting stuff within there. But the tool we're going to use is what's on my screen there, which is the WAT to Wasm file. And as you can see there, it translates from WebAssembly text format to WebAssembly binary. So again, feel free to go and spend some time and have a look at this toolkit. It's really, really cool. So what we're going to do just now, though, is download that onto our local machine so that we can therefore convert our WAT file to a Wasm format. So to do that, I'm just going to bring up my terminal. So my terminal, we need to git clone it into here. So I'm just going to do a git clone -- recursive, and then I'm going to pull that WABT repository that we saw there a second ago. So I'm just going to return that. And whilst that clones, it'll take a few seconds to do that. So now it's on my machine. If I just do an ls, you'll see I've got a folder called WABT. So let's just cd into WABT, and then you can see there's lots and lots of interesting stuff in there. The big thing that I'm interested in is I'm going to run cmake to compile the WAT to Wasm converter. So in order to do that, I need to install cmake on my local machine. So I will just do brew install cmake. If you haven't installed Brew already, go download Brew. It's going to make things a little bit easier for you, but I'm just going to run that just now because I've pre-installed that. And then again, it'll take a few minutes for it to install cmake, so we'll just give it a little bit of time, and then it will install that on my local machine, and then we can run the build. Okay, now that I've got cmake installed, what I'm going to need to do is create a build directory so that I can build the WAT to Wasm binaries. So I'll just create a folder called build. So make directory build. I'm going to cd into that. And then what I'm going to do is run cmake within there. So I've done that. So I've run my cmake. And then now what I'm going to do is run my make command also. So now that I've done that, I'm just going to run make. And it's going to sit and build that for me. It's going to take a little bit of time, and once that's done, then we will have the WAT to Wasm converter, and then we can convert that WebAssembly text file into our Wasm format. So now what I want to do is convert the empty module.wat file that I created earlier to that .wasm format. So to do that, I'm going to use that binary that I created 2 seconds ago, and I will just do a ... And it was in the WABT folder, and it was in the bin, and the name was WAT to Wasm. So that's the executable that I'm going to run. I'm going to put in empty module math.wat because that's the text format file that I want to convert to Wasm format. And to do that, I need to put -o. -o just basically means minus output. So give me the name of the output file that we're going to create. And in this case, we'll call it empty module.wasm. And if I just run that, it's going to take that file and convert it to Wasm. Okay, so now as you can see, there's now an empty module.wasm file created on my local machine. Now that the Wasm file is actually created, we can actually just inspect the contents of the Wasm file to see what it looks like. So if I just type in xxd, which is a Linux command, and then put in empty module.wasm, and then just run that, you can kind of see there's the binary code that's been generated, and there really isn't much to it. You can kind of see a 0061 and this 736D, and then this 0100, and we'll go into the details of what that means a little bit later on. But you can see it's a very, very small file, and of course it is in binary format. Now, if you wanted to see what the binary, although in this case it's really hexadecimal, but if you wanted to see what the file looked like prior to generating it, you can actually do that with the WAT to WASM converter as well. So let me just bring up the WAT to WASM again, and then this time, rather than doing a -o on empty module.wasm, what we can do is type in -v, and that is basically verbose mode, and then that will show you what the outputted version of the file would look like. So if I just run that, you can get a little bit more details there. So actually, as you see here, this 00617336D, look at the translation on the right hand side. So it gives you a sort of an understanding of the opcodes underneath that. So you can see here that this is Wasm binary magic. That's all that stands for, is 061736D stands for this Wasm binary magic. And then underneath that as well, you see 0100, and that is Wasm binary version. So this is an empty module, and essentially every WebAssembly module that you ever create will have this header because it must be present in everything that you do. Alrighty, so now that we've created our very first WebAssembly module, you probably figured that it's not very useful because I can't do anything with it in browser. What I really want to do is actually be able to call that from within my browser, load up that WebAssembly module, and execute that. So to do that, what we'll do is we'll just create a very quick function that will maybe square a number, and then we'll call that and then see it executing within the browser. Alrighty, let's do this. Let's create our first useful function. So the first thing I'm going to do is create another WAT file, and what we're going to do is we'll call this math.wat. So this is where we're going to store our square function. So we've got another WAT file, and again, I need to create a module as I did before. I'm just going to hit return, and you can kind of see the bracketing mechanism there, but I've got this module. Next thing I need to do is declare my function that I'm going to create. And this is just like creating any other function that you might create in any other language, whether it's JavaScript, C, C#, whatever, right? You just define what your function is going to be. So in this case, we're going to call it, the definition for a function is called func, and you see it lights up there. We're going to call our function square. So the dollar before that is just signifying what the name is going to be. We're going to have some parameters. So what we will do into the square function is we're going to pass in a number as a parameter, and then we will just essentially multiply that parameter by itself and then give the output of that. So we'll have a param in this case. So that's the sort of WebAssembly text format code for parameter, and it's expecting a number of i32. So it's expecting a 32-bit integer value. Now this is kind of where JavaScript and WebAssembly differ, because in JavaScript world, I can dynamically create variables. I don't need to define what their type is, but in WebAssembly world, it's statically compiled, right? So therefore, I need to know what the type of my parameter is in advance. So in this case, I have to specify that it's going to be a 32-bit integer. And then, of course, the next thing I need is I need a result. So the way you define what a result is in WebAssembly text format is by calling it a result. And again, you have to specify the output type. So in this case, it's going to be an i32. So I'm going to return a 32-bit integer. So now that I've got that, I'm not going to deep dive in this video what everything means in this WebAssembly text format. And the reason I'm not going to do that is we're going to cover that in some other videos, because it's going to get a little bit weird, because the way WebAssembly works is it essentially runs as a stack machine. And what I will do is explain what that is and how that works in another video. But for just now, just kind of bear with me a little bit on what's going on. So the next command that I need to sort of run, so this is the first sort of instruction, is I want to get access to that parameter. And the way that I do that is I need to pull the parameter and then essentially take that value and pop it onto the stack. Again, I'm not going to go into the details too much in this video. The way I do that is I run a local.get, and then I want 0. So I want parameter 0. So that param i32, whatever number I'm passing in, that local.get is going to pull that value, and then it's going to push it onto the stack. Again, in a future video, I'll explain what that means. And then I'm just going to do it twice. I'm being super lazy on this case, because I essentially need to multiply the same number by itself. So, and I need that to appear on a stack. So I'm just going to do a local.get 0 twice. And essentially what is happening is I've pulled this number twice and put it onto the stack. And then the last thing I'm going to do is I'm going to multiply those two numbers that I pulled onto the stack together. So I do this by doing i32.mul. And all that essentially means is i32 is, again, is an integer 32, 32-bit integer. It's the multiplication operation. And then to do the multiplication, it is expecting two numbers from the stack, right? And then whatever two numbers, the last two numbers that are on the stack, is going to pull them, and then it's going to multiply them together. So you can kind of see what's happened is, so I put the number that I passed in as a parameter onto the stack. I've done it twice. So I put it a second time. So if you can imagine the stack, let's say I'm multiplying 10 by 10. So I'm squaring the number 10. I would put 10 on the stack as the first item on the stack. And then I would put 10 on the stack again, because I've got it twice. And then the multiplication operation is going to pull the last two numbers, which is 10 and 10. And then it's going to multiply those two numbers together. That's the key thing. And then once it's multiplied that together, it's going to take the result, which in this case would be 100, and then it's going to put that onto the stack. Now remember, what I've done with these two items is, because I put them on the stack, in order to do the multiplication, I've taken them off of the stack, and then what will be left on the stack is the number 100 after the multiplication. So that's going to be 100, and then the result is really simple. What happens is a function in WebAssembly world will just return whatever the last item is in the stack. In this case, it's going to be 100, and then it will return that. Now, this is pretty complicated. I went through it really quickly there, but don't worry. In my next video, I'm going to spend a lot of time, and we're going to draw out the stack, and we're going to explain what the stack is doing, etc., so that you understand completely what's going on. But for just now, all I want you to see is essentially that I'm passing in a value. It's going to multiply those items together, and then it's going to return it. And we're going to get into a lot of depth on how that works underneath the hood in my next video. Okay, so now that I've done that, we've saved that. The last thing I need to do is just to export that function so that JavaScript can access it. So we'll just do export, and we're going to call it square, and I want it to return the function square. So there we go. So that's basically the equivalent of an export in JavaScript. So I'm just going to save that. I've created my math.wat. And now what I'm going to do is I'm going to compile that from WebAssembly text format back into Wasm exactly in the same way as I did earlier. So let's just come back onto my terminal. We'll bring up the screen. And what we will do is, in fact, let's just do a, let's do a wat to wasm verbose again, so that we can just see the binary. And I'm just going to put my math.wat in there. So let's just run that. And then you can see, oh my goodness, it's generated a lot of code there, right? I'm not going to go into the detail there, but you can kind of get the idea that it's generated the equivalent of my WebAssembly text format into binary format. So again, if you were to kind of look at this, you see in here that it's doing a local.get, it's doing a local.get, it's doing a multiplication, So it's the same sort of stuff there. I'm not going to go into the details too much here, but I just kind of want you to see that. So what we will now do is do the actual conversion. So as I did before, I'm going to call WABT to Wasm. And this time, rather than putting empty module, I'm going to put my math.wat, and then I'm going to output, so my -o, and I'm going to put math.wasm because I want to call it math.wasm. We'll just run that, and you will see it has created my math.wasm file, and then I can do my xsd math.wasm as I did before, and there you go, right? Here's our binary. It's really small. Do you see that? It's like really, really tiny, and you can kind of see square there, but it's a really, really tiny file. In fact, if I do an ls-la, you'll see that file is like 151 bytes, super, super tiny. So what we'll do now that we've created our Wasm file, we're going to execute it in two places. So the first one, we'll run it in nodejs, and then we'll actually execute it on a browser as well. So the first thing I'll do is I'll just create a new nodejs file. So we'll just type in npm init. I don't really care what it's called. I'm just going to hit return lots. That'll go create that. Let's open up Visual Studio Code. I want this to be a module because I'm going to be super lazy and I'm going to cut and paste this into the browser. So we'll just make that as a type module, and therefore that will allow us to use the import statement. And then I'm just going to create a new file, and we'll call it index.js. And then what I'm going to do is load the Wasm file, and then we'll execute it. So to do that, I just need to import fs from fs. So that's giving us access to the file system, and what we're going to do is just load the math.wasm file that we created earlier. So we'll just put const, and we'll call it math equals. So we'll just type in const, and we'll put in math wasm equals fs.read file synchronously, and then all I want to do is load it from the math.wasm location, which will do that. And then just for a bit of fun, we might as well just do a console.log on this and see what it looks like. So math wasm, I'll put my semicolon there, and then if we come back to my terminal, and we just run nodeindex.js, and you can see that it's returning the exact same bytecode as we had before. Now that we've loaded our Wasm file into a buffer, we're just going to instantiate that buffer as a WebAssembly file. So to do that, there's a command called webassembly.instantiate, as you can kind of see there. And now all you're going to pass into the parameter is an unsigned integer array using the math wasm buffer that we created, and then you can see it's going to do an export, and it was going to return me a module called math. So if I then just do a console.log math.square and then pass in the number I want to square, then it's going to execute that out. So if I just run that, go to my terminal, and then just type in nodeindex.js again, and you'll see it returns 100. So, and I can put any value I want in there. So 50, and it returns 2,500. The key thing is, as I sort of said before, is all I'm really doing is doing this WebAssembly instantiate. I'm passing in the Wasm file that I loaded up here, and then I'm exporting out whatever my exports are from my WebAssembly file. So in my particular case, I exported a function called square. And as you can see, that square function that I created in Wasm is available. It's been exported, and it works just like any other module or any other exported function that you would have in ES6. And so therefore I just call math.square, and it works. And that's super cool because, as I said at the beginning of this video, this interoperability between JavaScript and WebAssembly, where I can call WebAssembly from JavaScript and I can call JavaScript from WebAssembly, becomes key. So there we go. We have created our very first WebAssembly file by hand, and we've then executed that within Node.js. That's kind of cool. Now, just to complete the loop, what we're going to do is we're going to do the exact same thing, but we're going to do it within browser. So the first thing we need to do to make that work in a browser is actually create ourselves a very quick server. So I'm going to create myself an Express server very quickly. So we will call that server.js. So what I'm going to do is very quickly is just paste an Express server into the server.js file. So you can kind of see it's important Express, it's going to use port 3000, and then what I'm going to do is just serve up anything that is in the public folder. So let's just create a new folder called public. I'm going to take a copy of my math.wasm and I'm just going to stick that in the public folder so that we can serve that up as well. And then it's essentially going to return anything that is in that folder. So what we're going to do quickly is just check that the web server works okay. So if we just type in server.js, you'll see it's returned a module not found. So I need to obviously do an npm install --save express. That's just going to install for a second there. That's now working. And then I can run node server.js again. And you'll see it's listening on port 3000. And now if I bring up my browser for a second and I just go to localhost 3000, you should see that it is now returning hello world. So what I'm going to do now is I'm quickly going to create a new HTML file. We'll call it test.html. And what I'm going to do is I'm just going to paste in the code very quickly. It's a standard sort of HTML file, and all I'm going to do is call my square function and then output the result to the console. So if you look here, you can see I'm just running a script, which is script type is module. I'm calling webassembly.instantiate screaming, and I'm fetching the math.wasm that I just put into my public folder there. And then within that, on the return, you're seeing I'm essentially calling the square function, passing in the value 10, and then I'm just outputting the result to the console. So if I come to my browser for a second, we'll just put in localhost 3000 and test.html. And then if I go to the developer console, so if we hit developer tools, you'll see 100 is returned. And if I just go back into this and I change that value, maybe I put in 20, we'll just hit a refresh over here and you'll see it's 400. And then if I change this to a big number, maybe 100, then I would expect that to be something like 10,000 or whatever. And you can see 10,000. So what you're now seeing is that I'm running my Wasm file. I can run it on the back end with nodejs, but I can also run it in the front end via the browser. And that Wasm file is callable just like any other ES6 module there, and we can call the functions that we export, get the result back, and that is JavaScript and WebAssembly working together. So this is the end of our first so this is the end of this first video. Hope you enjoyed it. Hope it gives you a bit of a deep insight to how WebAssembly works. And in future videos, as I said, we're really going to get into a lot of the depth. So the next video in particular, we're going to focus on what the stack machine is. We're going to really look at some of the more complicated functions and what else you can do underneath the hood and what the various assembly instructions will be. So anyway, I hope this has been useful and I look forward to speaking to you in the next video. Speak soon. Bye-bye.